Welcome back, everybody. This is our 16th session in JEE Mains previous year questions for chapter Moving Charges and Magnetism of class 12th. Before this video, we have made 15 videos in this series, and all of those videos are available on our YouTube channel's playlist section. We have also started similar series for NEET previous years. So if some of your friends are preparing for NEET, then you can guide them through those videos also. And if you like these videos, then do press the like button, share them as much as possible, and subscribe to our channel. It helps a lot when you share and subscribe. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of donation, however it may be, will be highly appreciated. So with this, let's start today's video. And in the previous one we were around 110, so let's start from there. I think this was the last question which we covered, 107, and today we will start with 108. So let me adjust the thickness. So here, a galvanometer having coil resistance 100 ohm gives a full scale deflection when current of 1 milliampere is passed through it. What is the value of resistance which can convert the galvanometer into voltmeter of full scale deflection of 10 volts? So resistance of the galvanometer is 100 ohm and it gives full scale deflection, means that maximum current which can pass through galvanometer is 1 milliampere. Now we have to convert it into a voltmeter having a range of 10 volts. So our circuit will look like this, and in case of a voltmeter we attach resistance in series with galvanometer. So suppose we add a resistance R, we have galvanometer here, and that maximum current that can flow is equal to Ig and this is suppose point A and point B. It is mentioned that VAB is equal to 10 volts. So let's write the equation for current here. Ig will be equal to total potential, that is VAB, divided by the total resistance, that is additional resistance plus resistance of the galvanometer, Rg. Putting these values, we have Ig is 10 raised to power minus 3, VAB is equal to 10, R is unknown, and Rg is equal to 100. Now taking cross product, we will get R plus 100 is equal to 10 by 10 raised to power negative 3, and it will be 10 raised to power 4 or 10,000. And from this, R is 9900 or 9.9 kilo ohm. That is option D for us. So option D will be the right answer. Moving to the next one. In a circuit for finding the resistance of the galvanometer by half deflection method, a 6 volt battery and a high resistance 11 kilo ohm are used. The figure of the merit for galvanometer is 60 microampere per division. In the absence of shunt resistance, galvanometer produces deflection theta is equal to 9 when current flows in the circuit. The value of the shunt resistance can cause deflection to become theta by 2. So we have to find out what? We have to find out resistance of the galvanometer. So the potential we are using, that is of 6 volts, and resistance there is that resistance, high resistance of 11 kilovolt, that is in series with the galvanometer. So we can say resistance R that is already attached, it is 11,000 ohms. Figure of merit is given this. So we can say that is current sensitivity. So I by theta is equal to 60 microampere per division. Now let's discuss the first case in absence of shunt resistance. So case 1, that is no shunt resistance. In this case, our circuit will look like something this, that we have this resistance R that is of 11,000 ohm. We have a galvanometer here and we have a battery here. So galvanometer will have some resistance. Suppose that resistance is we will take it as G. Resistance of the galvanometer is G, and here we have battery. So current in this circuit will be I in this circuit will be the potential, that is 6 volts divided by this resistance plus resistance of the galvanometer. So 11,000 plus G. And as already mentioned in the statement, that in absence of shunt resistance, the galvanometer produces deflection theta is equal to 9. And we know that amount of current needed for unit deflection or 1 theta deflection. For 1 theta deflection, we need this amount of current. And if there is 9 deflections in the galvanometer, we can say that amount of current flowing in the circuit according to galvanometer should be 9 times the current required to produce unit deflection. And unit deflection produced by 60 microampere current, we are having 9 deflections, so this value should be equal to 9 into 60 into 10 raised to power minus 6. So now what we can write it like this, that 6 by 9 into 60 into 10 raised to power minus 6 is equal to 11,000 plus G. This will give on 10. Here we will have 10 raised to power minus 5. On top it will become plus 5. So 10 raised to power 5. This 9 will get multiplied here. So it will be 99,000 plus 9G. And this is 1 lakh. So 1 lakh minus 99,000, we will have 1,000 only. So 1,000 is equal to 9G, and from this 1,000 by G, 1,000 by 9 is equal to Z, that will be 111.1 ohms. So this is the value for, we can say, resistance of the galvanometer. Now going to the second part, case 2 with shunt resistance. Now with shunt resistance, our circuit will look like something this, that we have 11,000 ohm resistance here. This is galvanometer. Now resistance of galvanometer is known to us, 111, and here we have a shunt resistance in parallel to it, that is RS, and this is our 6 volt battery. So now our circuit looks like this, and we have to find value of shunt resistance, I think. Okay, so we have to find value of shunt resistance, and after shunt resistance, what happens here, that after shunt resistance, the amount of deflection reduces to half. The amount of deflection reduces to half in this circuit. So for that, again, what we have to do, as mentioned, that amount of deflection, here we can also solve it intuitively, that it is mentioned that amount of deflection is reduced to half. Now what will happen if it is reduced to half? Means the current that is flowing through this galvanometer, as amount of deflection is directly proportional to amount of current flowing through the galvanometer, the amount of current flowing through this galvanometer is reduced to half. Initially, in our first case, that amount of deflection was 9, and now deflection is 9 by half, and we can find out the amount of current by multiplying this to the current required to produce unit deflection. So as amount of deflection is reduced by half, means current flowing through this galvanometer is also reduced by half. Now suppose if there is some current I flowing through it, if circuit current is I, then how it will reduce by half? It is only possible that this current I splits into two equal parts when resistance of this galvanometer and resistance of this RS both are equal. Means when two resistance in parallel are equal, then current in them splits equally. When two resistance of equal resistance are in parallel, then current between them distributed equally. Means if I current was flowing in the circuit, then half of I will go through galvanometer and half will go through the shunt resistance. So that's only possible when their resistance is equal, and we know the resistance of the galvanometer, that is 111. So resistance of the shunt should be also 111 ohm, and if we compare it now, option B will be the right answer here. And we can also solve it in the proper manner, and let's also give you idea regarding that how that can be solved, as we will use slight approximation here so that we can arrive to answer comparatively faster. As we can see that this value of this galvanometer's resistance is 111 ohm, and when we have two resistances in parallel, then their parallel combination is always less than the lowest possible resistance. So suppose if RS comes out to be, we assume that if RS comes out to be, suppose 10,000 ohm, if actual value of RS is 10,000 ohm, then its parallel combination with 111 ohm resistance will give their final resistance that will be comparable to 111, because that's how parallel resistances work, that combined resistance or final resistance is always less than or equal to the lowest possible. So even if value of RS is very high, then it will comes out to be again near about value of 111, and if RS is very low, suppose if RS is 10 ohm, then their combined resistance value will come closer to the 10 ohm. In both of these scenarios, when RS is very high and RS is very low, the value of their combined resistance will not exceed 111 ohm. And if their value will not exceed 111 ohm, and here we have series with 11,000 ohm resistance, means these two as a whole plays a very minute role in deciding the amount of current flowing in this circuit, because amount of current in this circuit is given by voltage, that is 6, by this resistance 11,000 plus their combined sum or their parallel combinations final value, and that final value maximum value that these two in parallel can take 111, which is, we can say, ignorable as compared to this 11,000 value. So what we do here, we ignore this 111 resistance value so that our calculation can become slightly easier, and when we can reach to answer more fastly or in least possible time. So we assume that our current in this circuit is equal to 6 by 11,000, ignoring the these two's parallel combination, because it will be very small as compared to this. Now this is the value of current flowing in the circuit. Now value of current flowing through the galvanometer, or we can say Ig, current flowing through the galvanometer, will be 6 by 11,000 into, we have to find current through galvanometer, so we will take the other resistance, that is Rs. Let's take it as R, divided by their sum, that will be, galvanometer is 111 plus resistance R. So this is the current flowing through the galvanometer, and as mentioned, this produces theta by 2 deflection. Theta by 2, theta is 9, and by 2, and for one deflection we need 60 microampere. So for this we will 16 into 10 raised to power minus 6 ampere current. So this whole value should be equal to this current value. Now here we can do that. 6 will cut here. We take 11,000 on this side and 2 on this side. So we will have here 2R divided by 111 plus R is equal to 9 times 11,000 into 10 into 10 raised to power minus 6. This can be written as twice of R. 111 plus R is equal to 9 into 11, so 99 into 10 raised to power minus 2. Further we can write it like this: 2R by 10 raised to power minus 2 equal to 111 into 99 plus 99R. So from this we will have 2R by 10 raised to power minus 2 means 200 minus 99R is equal to 111 into 99, and from this we will have 101 R is equal to 111 into 99, and R will be 111 by 101, and this on solving will give us around 110 ohms, and that is our answer, option B. So we solved it by two methods, and any of which you can choose depending upon the which one you find the easier. Now moving to the next one. A galvanometer coil with its resistance 25 ohm requires a current of 1 milliampere for full deflection. In order to construct a meter of current reading 2 ampere, the approximate value of the shunt resistance. So we have to find out approximate value for shunt resistance. And in this, suppose this is galvanometer and its resistance is given. We have to add a shunt resistance, so suppose that is R. Now mentioned that its maximum current of the galvanometer is 25 milliampere, 1 milliampere. So 1 into 10 raised to power minus 3 ampere, that maximum current, and we have to measure 2 ampere through this circuit. So if 2 ampere current is flowing from source, then out of this 2 ampere, only 1 into 10 raised to power minus 3 or 1 milliampere current will go through the galvanometer, and remaining will go through this resistance, and that will be effectively 2 ampere because this is very small as compared to 2 ampere. So using potential equation, we can say that potential across this galvanometer is equal to potential across this resistance. Potential across resistance is the current flowing through it into resistance. Current flowing through it is, from the resistance, current flowing is 2 minus 1 milliampere, multiply its value, that is R, and potential across galvanometer is current across it into its resistance, so 1 into 10 raised to power minus 3 into 25. Now 1 milliampere is very small as compared to 2, so we ignore it. So twice of R is equal to 25 into 10 raised to power minus 3, and R is equal to 12.5 into 10 raised to power minus 3, or but we can write it like 1.25 into 10 raised to power minus 2. Option D will be the right answer here. Moving to the next one. When a current of 5 milliampere passed through a galvanometer having coil resistance of 15 ohm, it shows full deflection. The value of resistance to be put in series with the galvanometer to convert into voltmeter of 10 ampere or 10 volts. So full scale deflection means Ig is given, that is 5 milliampere. Resistance of the galvanometer is 15 ohm, and we have to find the value of R. So we know that I will be 10 by, that is Ig, 10 by resistance plus resistance of galvanometer, that is 15. So using these values, 5 into 10 raised to power minus 3 is equal to 10 R plus 15. From here, R plus 15 is equal to 10 divided by 5 into 10 raised to power minus 3. So it will be R plus 15 is equal to 2000, and R will be 1985 ohm, or 1.985 into 10 raised to power 3 ohm. That is option C for us. Moving to the next one. Galvanometer having coil resistance of 100 ohm gives a full scale deflection when a current of 1 milliampere is passed through it. So coil resistance, now we have to convert galvanometer into ammeter to give a full scale deflection of 10 ampere. So this is our galvanometer. Again, its current is 1 milliampere, and we have a shunt resistance R here, whose value we have to find, and original current is 10 ampere. So we can say current flowing through this resistance R is 10 minus 1 milliampere. 10 minus 1 milliampere multiply by its value. It is the potential drop across this resistor, that should be equal to potential across galvanometer, and that is 1 into 10 raised to power minus 3 into galvanometer resistance, that is 100. So ignoring this value, as compared to, as 1 milliampere is small as compared to 10, so 10 R is equal to 10 raised to power minus 1, and R is equal to 10 raised to power minus 2, or 0.01 ohm. That is the final value here. So here we have next question. A 50 ohm resistance is connected to a battery of 5 volts galvanometer of resistance 100 ohm to be used as ammeter to measure the current through the resistance. For this, a resistance Rs is connected to a galvanometer, which is the following connection should be employed if measured current is within 1% of the current without the ammeter in the circuit. Rs in series with value in galvanometer, Rs in series, Rs in parallel, and Rs in parallel. So here we have to measure resistance without the ammeter in the circuit. So with and without the ammeter, we have to measure the resistance, we can say current in the circuit, and then we will find out the value of Rs. So first slide it down, and first solve the for. First we will find out current without ammeter, and then we will solve for with ammeter. So without ammeter. Now without ammeter, our circuit will look like this, that as ammeter is not used means galvanometer is not used, and if galvanometer is not used, then there is no parallel resistance with it. So we have basically a 50 ohm resistance with 5 volt battery. This is our without ammeter circuit, and from this I will be 50, 5 by 50, that is 1 by 10 ampere. This is the current. Now let's with ammeter. With ammeter, our circuit will look like this. This is our 50 ohm resistance. We have a galvanometer here, and if we have to use galvanometer as an emitter, there should be a resistance in parallel. So this RS is in parallel. So we can say both series options get cancelled. Only parallel answer will be possible. So this is R, and we have a 5-volt battery here. Now resistance of the galvanometer is 100 ohm. Now let's find out total current in this circuit, that is suppose I dash. So to find I dash, we need total resistance, and total resistance, for that we first need to solve parallel combination of R and 100. Their resistance will be 1 by R plus 1 by 100, and R dash will come out to be 100 R by R plus 100, and total resistance of this circuit will be 100 R plus R by 100 plus 50 ohm. So we will keep it as it is, and now current in this circuit will be 5 by total resistance, that is 100 R by R plus 100 plus 50. And now current measured by the galvanometer, because in galvanometer we will have only Ig flowing through it, and it will only measure this value. So Ig will be here, this I dash will divide it into two parts. One is Ig and the remaining which is going through R. So we have to find Ig, and Ig will be R divided by R plus 100 multiplied by the actual current, that is I dash. So it will be Ig is equal to R plus 100 multiply this value, so 5. Here we have to take LCM, so 100 R plus 50 R plus 5000 divided by R plus 100. R plus 100 get cancelled, and we have here 5R divided by 150R plus 5000, and we further write it like R 30R plus 1000. So this is the value which galvanometer will measure here, and as per statement that this measured current is within the 1% of the current without the emitter in the circuit. So this current should be in the 1%, within 1% of this value. So using these two, as mentioned, that here Ig, which is Ig, is this value. Ig is within 1% of I. So this current R, Ig, that is R by 30R plus 1000 is 1% of this. We can say 1% will be 1 by 100 of I, that value of I is 1 by 10. So solving these, we will get 1000 R is equal to 30 R plus 1000, and from this 970 R is equal to 1000 and R will be 100 by 97, that is approximately equal to, I think that will be around 1.1 ohm. And if you match the answer now, that is option C will be the right answer. Now let's move to the next one. To know the resistance G of a galvanometer by half deflection method, a battery of EMF VE and resistance R is used to deflect the galvanometer by angle theta. If shunt of resistance S is needed to get the deflection to half, then G, R and S are related by. So again we have solved similar type of question, that is with and without shunt. So here we will have two cases. So first is without shunt resistance. Let me make it slightly more thinner. So without shunt, our circuit will look like this, that we have battery and resistance and a galvanometer. So this is our resistance R, we have a galvanometer here, and we have battery here with EMF V. So here current in this circuit will be equal to potential by this resistance plus resistance of galvanometer, that is G. And this current, as mentioned, deflects galvanometer by theta, or means I is proportional to theta. This is first relation. Now coming to the second part, where we attached a shunt resistance. So with shunt resistance, now with shunt resistance, our circuit will look like something this, that we have a resistance R, we have a galvanometer, we have a shunt resistance of value S in parallel, and we have a battery here. So what we again do, we have to find the value of current that is flowing through the galvanometer, and for that first we will find the value of the current I that is flowing in this circuit, and then we will split that value I into Ig and Is. We need Ig here. So for I we need total resistance of the circuit, that we have R and G and S in parallel. So first G and S we will solve for parallel GS and then add them to R. So 1 by G plus 1 by S will give us GS S plus G, or their final resistance in parallel will be equal to GS plus S plus G, and total resistance of the circuit will be R plus GS by S plus G. This is total resistance. Current in the circuit will be V by total resistance, that is R plus GS by S plus G. This is total current in the circuit. And now splitting this current into Ig and Is, Ig will be equal to original current, that is this R plus GS by S plus G, multiply by, as we have to find through galvanometer, so we will take opposite resistance S divided by total S plus G, and this will be equal to S plus G we can cancel after taking LCM. So it will be S into V divided by RS plus RG plus GS. Now this is the galvanometric current in this circuit, and it is proportional to half theta, or half of the theta. So it is proportional to theta by 2. Now using this equation that this current is proportional to theta and this current is proportional to theta by 2, we can divide both of these. This is equation 1, this is equation 2. So dividing both, we will have SV by Rs plus Rg plus Gs divided by this value. So we have V here and R plus G here is equal to theta by 2 divided by theta. So that gets cancelled, V get cancelled, and here we have twice of SR plus twice of SG is equal to Rs plus Rg plus Gs. So this value come here in the subtraction and this value come here in subtraction. We will get SR plus Sg is equal to Rg, and from these two we can take S common. So SR plus G is equal to Rg. Now let's compare these. SR plus G is equal to Rg. So that is our answer here. So with this, we end this video here. Hopefully what we have covered is helpful to you. Again, if you find these videos meaningful, then do press the like button, share them as much possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.